Hello folks, we come to the exercise 1.4 and this is a part 1 video. Here we are checking about the binariness of a particular operation. Binary means once you define an operation, the result that we get after applying the operation, it should belong to the same set from where we started. If it belongs, it's binary. If it doesn't belong, it's not binary. So that is the meaning of that, and it's a operation that becomes binary and the set becomes closed. So these are two things which goes hand in hand. After applying the operation, when the answer does belong to the set becomes closed and the operation becomes binary. So that's how it is. So we have this is question number 1, in which we have the first subpart, which is defined on z plus integer, positive integers, a star b defined as a minus b, whether it is belonging to z plus or not. That's what we are checking. Now for when we check for a and b belonging to z plus, if it's an integer, positive integer, automatically, it is positive integer that is defined. Let me clarify. Yeah, a minus b always need not be belonging to z plus, right? So it's enough if we give a counter example. So suppose if we have, say, maybe 2 or 3 to start with, 2, 3 belonging to z plus, suppose if you take, therefore 2 minus 3 is minus 1, and this doesn't belong to z plus, right? It doesn't belong. So because it doesn't belong, it is not binary. So we'll say star is not binary. Right, that is the meaning of binary. Then we take the next one, z plus a star b is ab. So this will be true. So for a and b belonging to z plus, a into b will also belong to z plus. It's not a big affair, right? You multiply to positive integers, it is going to be positive, right? So it is going to be belonging to z plus. So therefore a star b belongs to z plus. That way star is binary, right? Then we have r on real number, a star b defined as ab square. This is also quite obvious. For a and b belonging to r, a dot b, right? A into b into b, the product will also belong to r. So that way a star b will belong to r, and that is why star is binary. Right, products generally, they do good work, right? Then on z plus, you have a star b defined as modulus of a minus b. See the difference between these two? Because you have taken the modulus, it will now belong, right? There was no modulus, and that is why it was creating trouble. So you can have for a and b belonging to z plus, a minus b modulus is always a positive value. So therefore it is going to belong to z plus. There's absolutely no doubts about it. That way a star b belongs to z plus, and that's how star becomes binary. Then on z plus, you have a star b defined as a. A is already there in z plus, right? And it's defined as a, it will be in z plus. See, for a and b belonging to z plus, they're already in z plus, right? So a in particular is in z plus, and this a is a star b actually, right? So a star b belongs to z plus. Have we got it? Because a is what is a star b. So like that, star is binary. So it's only the first example which was not binary. All the other examples are binary. Just checking if everything is done. Yes, that's about it. And I think we should be, because it's a tabular lot, we will, question by question we will take, because otherwise it will be a messy affair. So in the next video, the next question. Thank you.